Hi everyone, my name is Kuba Misiorny and I'll be talking with you today about artificial intelligence and how it can help us humans with our human intelligence and how the Cambrian explosion in deep learning is driving all of that forward. So Steve Jobs had this story that I refer to as the bicycle of the mind story, and it goes like this. There was this article in the Scientific American in the 1960s where they measured the efficiency of movement for all those different species. How many kilocalories, how much energy they expend to get from point A to point B. And the condor came in at the top of that list, surpassing all of the other species, including humans, who actually fared quite badly about the third down the list. Not such a great showing for what we think of as a pinnacle of evolution, right? But then an interesting thing happened when someone at Scientific American had the imagination to test the efficiency of a human on a bike. And a human riding a bicycle blew away the condor all the way from the top of the list. And that made a really big impression on me, that we humans are tool builders. We can fashion tools that amplify our inherent abilities to spectacular magnitudes. And one thing that's even more interesting about tools is that, select animals can have better speed, better eyesight, better smell, so they excel at this one very specialized task. But that's it, that's their core strength. And the amazing aspect of building tools is that you can build many of them and switch them up to suit the task at hand. So at that time, the story was that the computer was really the bicycle of the mind, the tool that we build to amplify and multiply our abilities to think, the abilities of our mind. And that tool building aspect of humanity stems directly from our ability to think. So it's natural that we're trying to build tools that will enhance this ability and help us think better. So how is that different from having computers? Now it feels we're at the brink of another revolution. AI is the next generation of tools that will enhance our work even further and in a completely new way. So I would argue in a broader sense that we've lived with augmented intelligence in an augmented intelligence age since the computers were really invented. And it became widespread with the internet, and even more so when mobile phones became ubiquitous. I read this beautiful story online recently where the argument was that since people have this ubiquitous access to the internet, especially through mobile phones, so essentially they have access to the sum of the humanity's knowledge. They can access any fact instantly. And so the argument there was that they're gradually forgetting how to think. But I disagree. We have to distinguish between the data retrieval aspect and the reasoning that comes from that's built on this data retrieval. Thinking is really so much more than recalling facts. And we'll see in a second how that relates to the AI and the augmented intelligence, and how much there are still those tools that are still in this data retrieval space rather than in a thinking creativity space. And rightly so. Those tools, the strength of computers is in processing a lot of information fast and precisely. And that's the thing that we humans are not so great at. What we are great at is things that are uniquely human, creativity, reasoning, connecting different seemingly unrelated facts together. So we can use the technology, computers, to automate and process faster this data retrieval step, and we humans come in at the thinking and creativity step. So if we frame artificial intelligence in that context, that it's a tool to help us think, how is it different from the last 50 or 60 years when the computers were introduced? So how is it different from the traditional computing? What's so special about AI, and even more so specifically about deep learning? And this is the thing I want to convey in this presentation. So to give you the high overview of my and my company thinking about this, let's zoom out a little bit and think about robots. Why is Boston Dynamics and other companies, notably Tesla recently, why are they developing humanoid robots? It's very difficult to build a robot that walks, especially on two legs, and that can operate human hands, for example, humanoid hands. It took them years, more than a decade, to develop this robot that can balance on two legs and walk autonomously. So this robot that's we see on the screen, this is the Boston Dynamics Atlas robot. In the same vein, it's much easier to build a robotic train locomotive than build self-driving cars, right? Or even easier to build robots that don't move at all, and like in factories where the materials come to the robots in a structured and predictable way. And of course, we know the answer to that. It's very obvious, because an alternative to self-driving cars are those robotic trains. We have those, right? But the challenge here is that you need to build all of that supporting infrastructure around the robots so they can operate. In the case of the robotic train locomotives, is the train tracks. In the case of the factory robots, is the factory all around them, right? And we've done that, and it's very hard to do more of that, right? If you wanted to have a replacement for self-driving cars, you would have to build train tracks to everywhere, to every house. And of course, there is a limit of how much of the world we can structure and change so that it is suitable for robots and it's accessible to the robots, right? I think that's the key aspect of this, how much of the world is accessible to a certain robot. And it's clear that most of the world is already designed and made accessible to humans, right? It's made by the humans for the humans. And so to be able to access that world, I would argue you need to at some point emulate humans in one way or another. And so the Atlas, Boston Dynamics Atlas, is an example of being able to access the physical world, physical human world. And it's the same story with the knowledge world, right? The information world. I'll explain this slide in a second. And so looking at unstructured data, for example, in the form of text, most of it is made by humans and for the humans, right? All the contracts that we write, emails, instant messages on Teams or Slack, all of those are made for other humans, not for the computer, not for computers. Even computer code is, while it has to be understood by the computer, the sort of joke that's actually very true is that it is made for humans to read. So the ancient wisdom in software engineering is that you're writing the code really for the next programmer that will be reading it, even though that next programmer might be you. And there's even more dramatic version of that saying, but I think it's great to keep that in mind when you're on your journey to become a proficient software engineer, is that you should write your code so well. In fact, you should write it so beautifully in a readable and pleasant manner, as if the next engineer that will be working on it is a psychopathic killer that has your home address. But I digress. Back to the structuring the world around us for computers. So to be able to access the knowledge and the information world, and interact with it, you need computers that think like humans, or at least are able to understand human language in all of its messiness and lack of rigid structure. So previously, in a traditional computing sense, the strategy was to take that unstructured world and structure it so that the computers can then process that. So for example, imagine having 5,000 legal contracts that are scanned paper documents. How do you find all the contracts that provide certain warranty or rebate structure? This is not something that you could extract out of the documents with a keyword search or a rigid structure rules. Even if you manage to do that for those 5,000 contracts, it would break the second you added one more. So traditionally, you would farm it out to human intelligence operators, namely interns, or use services like an Automatic Turk or Upwork or Freelancer.com, right? That's how you structure the unstructured world. So then computers can come in and provide their unique benefits of being able to process that structured information fast and efficiently. And that's where the new wave of natural language processing algorithms and models shine in. As with humanoid robots, NLP, so natural language processing, allows us to interface with that human world and do things human couldn't do or would take too much time to do, right? So what if we change those 5,000 contracts into 500,000 contracts, right? It would take weeks and weeks of intern work to do. And if that was more complex or there was some judgment to be done on every contract, you would have to use more senior people, which would take even more time and more cost. And so this is where the deep learning and comes in, right? The recent Cambrian explosion in the NLP space with transformer models and attention mechanism allows computers to begin to understand this unaltered, unprepared human world, right? So we can feed directly the documents and information that we consume as humans to the computers. But so what, right? Humans understand human world. Why do we need to use computers? Computers bring this unique value to the table. They can process vast amounts of data and very quickly. Once you are able to nail some model or some type of information or documents, you can go through more very quickly. So the computers can attain this perfect visibility of huge quantities of data. But making decisions based on that data is a whole other story. And for mission critical applications, you want to have this human judgment mixed into the reality and the models. And this kind of approach is called human in the loop. But I'm a big fan of that term that we've been discussing, and that's the title of this presentation, augmented intelligence. So augmented intelligence, more formally, is this design approach to developing intelligence systems in a collaborative way, with a slightly different, or actually very different objective than you typically design artificial intelligence systems with. So with augmented intelligence, you focus on improving the decision-making abilities of the humans. You're not focusing on AI to completely automate something in the first place. So you build the support for the humans to empower the humans so that they can work more effectively and actually more efficiently and ultimately attain better results. So my company, Untrite, has this definition of augmented intelligence at the core: to help people make better decisions and augment their work. Suffice to say, we're big fans and proponents of augmented intelligence. So bring this human and computer perspective to get together. And we love the metaphor of an Iron Man suit where we try and build technology that gives humans superpowers rather than tries to replace them. So let's look at two examples of deep learning based augmented intelligence solving real world problems. So say you're a support engineer and a client has a problem with one of the machines that you've sold them. So what kind of information will you need to efficiently and effectively help that customer? You probably need some information about the client that lives in a CRM system. You will want to know about the history of the issues that this client had before, which probably lives in some customer support system. You want to know the list of the machines and other products that you sold them. That's probably in a completely other system, an accounting system, for example. You will want to know the history of the issues of that machine to see if there was something similar there. You'd want to know then how to debug that machine to see if that's the actual issue that they have. This can be in any sort of places, files on SharePoint, shared drive, probably some PDFs with user manuals or debugging manuals. And then even more so, you want to kind of action that issue with some steps for the customer to fix that machine. And there's probably much more information that you can find that can support that solving of that issue. And that takes a long time to find all of those documents, right? And it's very costly for you, for your company, especially if you have to have people that are highly skilled and highly specialized that are doing this kind of support work. And one thing to highlight here is that each piece of the information here is in a different system. It's in a different format and probably written somewhere in a free text, right? Because it was written for other people, not really for computers to understand. But what we would want here, right, is to be able to have this context, all of this information in one place for each of the support requests that the customers are sending to us. So that we humans are concerned with understanding this information, verifying that it's actually that issue, the specific issue that the customer is having, actually having the conversation with the customer, building this human connection, and that's it. We don't want to concern ourselves with retrieval of that information, with finding that information, finding the systems that have that information, and so on and so on. So is that possible with AI? We've designed a system that uses deep learning, NLP, natural language processing models, that does exactly that. So those NLP models will understand the language in all of those different documents, and more precisely, they can understand the meaning of single words, the sentence and paragraph. So it's not looking at keywords or kind of text level data. It's looking beyond that, as exactly as humans would do at the meaning of things, right? So you can spell things differently, you can say them differently, but the system knows that you mean, for example, the same thing. And through that automatic understanding, we are building this ephemeral map of all the information in the whole knowledge landscape of the company. We're building that map that relates to this very specific issue. So based on the description of the problem, like in our example, fuel engine reporting faulty, we're able to map that to an error state that lives on the intranet of that company and find a cause of that error state, that the velocity monitoring is broken. But those two things don't really share any keywords with each other, but we can find from the description of that error state that this is related. Even more so, we can then follow the breadcrumbs of that error and understand that this site on our internet prescribes some actions to take to fix that issue. So the action here is to replace the speed sensor. And so the NLP models will understand that and take us to a PDF of a user manual that talks about replacing the speed sensor, and it will take us directly to that one paragraph that is talking about that issue. Well, talking about that, fixing that issue. And even more so, the NLP platform will understand that the model number of that speed sensor is XYT46, and will take us to the spare part Excel spreadsheet that tells us which order ID that speed sensor will have, and that can take us directly to our ERP where we can order that part. And all of that information, imagine having all of that information for each issue. All of this context presented to you automatically, so you can make the decisions faster. You can execute the decisions faster. Imagine having that tool when you're just onboarded with the company. You don't have to know that you have to go to this ERP or that shared drive or this CRM. All of this is presented to you with deep links directly to all of those systems. Because we not only don't want to replace human thinking, we don't want to replace any other system. Those systems are there for a reason, right? The ERP system takes part in a lot of other processes in the company. We just want to link directly to it for this very specific customer service task. And so, because we need that system, we want that system, we built it. So here is an example of Jane Dobson raising an issue in our Jira service desk, and we present the whole context of the context created from the information landscape, from other systems, from SharePoint, from Google Drives, etc., where we support the customer service agents or customer service engineers, or even regular engineers that are doing customer service. We help them find the right information at the right time for the right task. But we can take this even further to even more mission critical aspects of our world. This is where the augmented intelligence can literally save lives. So this is the work that we've been doing with the police in the United Kingdom. When you call the police on emergency number 999, the operator on the other end, they have a very difficult job. They have to do things very quickly, very efficiently, talk to you as a member of the public, calm you down, support you, and be there for you as a human. But in addition to that, they have 20 to 50 different systems, depending on the police force, where they have to look up some information, follow a checklist, and do this in a time-pressured environment, in an emotionally charged environment, all while being professional and supporting you, also emotionally. There's this saying that no one ever calls the police in the best time of their lives. Most of the calls to the emergency services are at a very worst times of people's lives. So obviously they will be chaotic and stressed. So our system here has a couple of different aspects of deep learning that help us help the operators at the police station and the control room of the police station, and through that help the whole public. So we have a speech-to-text module that uses deep learning models to understand different accents, different emotions, and take that audio of the conversation, convert it to text that we see here in our demo. And then we have very different deep learning models that analyze that text and surface relevant information from it. So the system understands names, can categorize events, understand addresses, understands mentions of weapons, drugs, contraband, etc., etc. And then based on that understanding of the conversation, of the audio of the conversation, we can match that understanding with understanding of the whole information and knowledge landscape of the police. So remember, I mentioned that the police officers have access to 20 to 50 different information systems at any point. All of those systems are separate. They require separate login, separate browser tab, or separate desktop application to access them. Our system can access those systems in our platform can access those in the backend. And understand and build that context for the operator based on the situation at hand. This wasn't possible before because all of those information systems, as I talked about before, they are all built for humans, for human consumption, which most of the time means that all the descriptions of previous crimes, of vehicle registrations, of suspects, of victims, of vulnerable people, all of them are in free-form text. And you cannot use a simple keyword search to search through those, right? You have to understand the meaning behind the language to be able to effectively build that context for the operator. And this is all that we want to do here: build that context, find out if someone is registered in a vulnerable people database, find out their dependents, find out the vehicles that they have registered with the police, etc., etc. And so we bring all of that information in one screen to the operator, and then support them in the hard work that they're doing, support them in understanding the situation and making and ultimately making the decision of how to handle it. We are starting to build another layer on top of all of that understanding, and this is the Thrive model here that you see on the top of that screenshot. So Thrive model is a triaging tool used by all of the police forces in the UK that aims to normalize and standardize the way police officers are doing triaging and valuation of cases of cases in the emergency and non-emergency calls. And this triaging, the Thrive modeling, where you score each case on a couple of constituent elements like threat or harm or risk. This is all done subjectively by the police officer. So we are bringing another deep learning model that looks at the entirety of the information that we have here, that we surface from the information systems and from the call, and display the calculation of the score that the model is outputting. And this is by no means meant as a replacement for the police officer. It is meant as an aid so that the police officers can compare their judgment to the judgment of the computer. But the police officer is making the ultimate decision. The aid here is that if the police officer is thinking to themselves, right, this is very low in the triaging tree, I will send a unit in a day to investigate it. But the automated system is saying this is very high risk. You have to send the unit right now. The officer can dig through that model because we are using explainable AI here. They can dig through that and understand, all right, you're suggesting I should send a squad car right now because someone mentioned a weapon or an assailant or someone aggressive, right? And they might have missed that in the conversation, right? Because they're having 20 different conversations in a day, all of them highly charged. They might be tired. We're all humans, and this is a very demanding job. That's why this AI augmented intelligence system can help alleviate that stress and help the officers to be sure that they didn't miss anything. Thank you very much. Of course, I've just scratched the surface of how those powerful new technologies are helping the world and how they can be applied to make our lives easier. I hope this introduction was enough to pique your interest. And I believe there is some time for questions right now. I'm also available on LinkedIn or through the email that you see here. If you have any questions and would like to talk to me, I'm always happy to share our knowledge and talk to new people. Thank you very much. Bye-bye.